Today, we're jumping right into a crime scene, but this is one with no weapon, no fingerprints, and zero witnesses. We're diving into the world of digital forensics, where every single click, every connection, every command can be a critical clue.
So let me ask you something. A crime has been committed, but the scene is spotless. There's no physical evidence. Nobody saw a thing. How do you even begin to figure out who did it?
Well, you turn to the computer, you see, in the digital world, every single action leaves a trace. It's like a digital fingerprint, just sitting there waiting for someone to find it. All right, so how does this actually work in practice? Let's walk through a digital crime scene together and see exactly how an investigation like this unfolds. So here's our case. An employee's computer is just acting weird. The suspicion is that someone plugged in a malicious USB device. It's often called a rubber ducky, and it looks just like a normal flash drive, but it actually acts like a keyboard, injecting malware in seconds. The big problem? The device itself is long gone. So our mission is to find the digital proof that it was ever there and uncover what it did. Okay, so where do you even start? In any investigation, you have to find that first thread to pull, right? The first piece of hard evidence that places your suspect at the scene of the crime. Our investigation begins with a really simple question. Was an unknown USB device ever even here? I mean, before we can get into the what and the how, we have to prove that something happened in the first place. To answer that question, investigators follow a pretty clear three-step process. First, they check the system's setup logs. Then, they dive deep into the Windows registry. You can think of that as the computer's central nervous system. And finally, and this is the most important part, they correlate the evidence from both of those places to build a concrete timeline. So these two key artifacts, they really work together. That log file, the setup API dev.log, it's basically a timestamp security camera. It tells us the exact moment a device was first plugged in. And then there's the USB store registry key. Think of that as a building sign-in sheet. It records the make, model, and unique serial number of every storage device that's ever been connected. And here's where it all comes together. Both of these artifacts contain a unique identifier, a container ID for the USB device. It's like its fingerprint. By matching that ID between the log and the registry, investigators can say with absolute certainty, this specific device was connected at this exact time. Boom, we've just placed our suspect at the scene. Okay, so we've proven the USB device was there. That's a huge first step, but really it's just the beginning. Now we have to figure out what it did. It's time to follow its digital footprints through the system. One of the most valuable footprints you can find is something called an LNK file. Just think of these as digital breadcrumbs. Windows automatically creates one for almost any file or program you open. And crucially for our case, it records the file's original location, even if that file was on the USB drive that's now long gone. But you might be wondering, what if the attacker tried to cover their tracks by deleting files? Well, that's where the recycle bin gets really interesting. See, when a file is deleted, Windows creates two new files. The $I file is like a receipt. It records the original file's name, its path, and the exact time it was deleted. Then there's the $R file, which contains the actual contents of the deleted item. This just goes to show how hard it is to truly delete something. As this quote points out, even when the recycle bin has been emptied, it is possible to search for the info records to find all of the files that have been put in the bin. So even if someone thinks they've covered their tracks, these record files can often be recovered, giving investigators a perfect list of everything the user tried to get rid of. So we found some solid clues on the hard drive. But in our rubber ducky case, this is where the trail goes cold. The malware was designed to run without leaving many traces. To find the smoking gun, we have to go deeper. We need to look inside the computer's short-term memory, its live RAM. This is where the action is happening right now. It's the most volatile part of the crime scene, sure, but it's also the most revealing. This technique is called memory forensics. By capturing a snapshot or a dump of the computer's RAM, investigators get a perfectly preserved picture of everything that was happening at that exact moment. We're talking every running program, every open network connection, and even commands that were typed into a terminal. So the analysis begins with a simple question. What was the computer actually doing when we took this snapshot? Using a command called pslist, investigators scan the list of running processes, and yep, there it is, a PowerShell process that has no business being there. You see, PowerShell is a super powerful scripting tool, which makes it a favorite for attackers.
This is our prime suspect.
Okay, we have our suspect process. The next logical question is, was it communicating with anyone outside the network? And the answer is a big yes. A network scan shows an active connection from that PowerShell process to a suspicious IP address. The malware was phoning home, sending or receiving data from the attacker's server. We're so close. We know the malware is running, and we know it's communicating. But what exactly did it do? What commands did the attacker type? And here it is, the smoking gun. A command called cmd scan searches the memory for command line history, and it finds the exact command the attacker used, an instruction to download and execute a Metasploit payload. That's a well-known piece of malware. Case closed. So we've gathered all the evidence, from the hard drive all the way to the live memory. We found the digital fingerprints, we followed the footprints, and we found the smoking gun. Now it's time to connect all the dots and tell the complete story of this attack. Here's how it all comes together. At 12:01 and 15 seconds, the system logs show our rubber ducky was plugged in. Just 5 seconds later, our memory analysis proves a PowerShell script began running. 10 seconds after that, the command history shows it downloaded malware. By 12:01:30, it was phoning home to the attacker. And finally, LNK files show that by 12:02, it was already accessing the user's private documents. A full-blown attack, from start to finish, completely reconstructed from digital ghosts.
It just shows you that even when a crime seems totally invisible, the evidence is always there, waiting in the logs, the registry, and the memory. It just leaves one final thought. What story is your computer waiting to tell?